Assalamu alaikum everyone, and welcome to another session on forecasting. Famous economist Paul Samuelson once said, Wall Street indices predicted 9 out of the last 5 recessions. We would like to know from our expert Dr. Muhammad Abbas Chaudhary how one can predict 9 out of the 5 recessions. Another economist, Edgar Fiedler, once said that if you ask a question from 5 economists, you will get 5 different answers. 6 if one of them went to Harvard. Still, he says, if you have to forecast, forecast often. In the last session, we discussed quantitative methods of forecasting, time series forecasting, in which we discussed decomposition of a time series, naive approach, moving averages, exponential smoothing with trend adjustment. Our agenda for today's session is exponential smoothing with trend adjustment, trend projection using least square method, coping with seasonal variations. Now I will request Dr. Muhammad Abbas Chaudhary, our expert, to advance our understanding on forecasting. Sir.
Well, thank you, Ayesha, and viewers of online Commonwealth of Learning. Ayesha mentioned Paul Samuelson and Edgar Fiedler, 2 very prominent economists. I think Ayesha raised a question in the words of Paul Samuelson and then answered in the words of Edgar Fiedler. You will recall that forecasters never say with certainty that this is going to happen. Forecasting is a discipline which deals on statistics and probability, terms of probability. As such, when a forecast says this or this is going to happen, or then they call there is a chance of this happening. They never say that there is a 100% chance of this thing will happen or this thing will not happen. As such, when we say we are forecasting or forecasts say such and such, or as Paul Samuelson said, 9 out of 5 recessions, that means it was a chance. The Wall Street indices indicated that there is a chance that 9 recessions could occur. 9 didn't occur, only 5 occurred. Okay, that is the game of probability. That is number 1. In forecasting, we always talk in terms of chance of happening such and such. That is one thing or one explanation of what Paul Samuelson said. The second explanation is that while we predict that something odd is going to happen, people get ready. Okay, you know, when somebody focuses a punch, you get ready to it. When somebody, Wall Street indices predicted that there is a chance of a recession happening, it means all the forces, all the economic forces, they get readied, and in doing so they averted the recession. Means otherwise that could have happened, recession could have happened, but it didn't, because all the economic forces, they get readied to avert that or to confront that. As such, the recession didn't happen. 2 things. 1, forecasting is always in terms of chance, probability of happening such and such or not happening such and such. 2, once something is predicted, the forces get ready to that to avert that happening if it is adverse. And that is why the Edgar Friedel said, if you have to forecast, forecast often. Similarly, I think a forecast is a useful survival tactics in bad times. The master of wit, Oscar Wilde, once said, to expect the unexpected shows a thoroughly modern intellect. It means when there is something, you expect something is going to happen, then you prepare for that. And forecasting is actually a discipline that prepares us for really if something, what is going to happen, and we should be prepared accordingly. Now, coming back to our quantitative forecasting methods, we were discussing last time, Ayesha, you mentioned exponential smoothing. We have covered exponential smoothing using various values of alpha and so on. We'll continue two other very important issues as far as exponential smoothing is concerned. One is the trend. In how do we capture if there is a trend in certain sort of data, and how the seasons are to be taken care, because we know demand or production or something, it has to do with something. In summer, let's say certain commodities are in demand, in winter there are some others. How the seasons effect on our forecast, we'll be discussing that. The exponential smoothing, as far as trend is concerned, when the trend is present, exponential smoothing should be modified. And how that is modified? This equation tells us forecast including the trend is equal exponentially smooth forecast plus exponentially smooth trend. Okay, let's see how it happens. This is actually in mathematical form the equation which we discussed, and it takes 3 steps to calculate the forecast using exponential smoothing and adding a trend into it. Step 1 is we compute FT. We compute the forecast, then we compute trend, and then we calculate the forecast by adding trend to the forecast. Now, let's see an example of how exponential smoothing is adjusted using the trend, how trend is added to the exponential smoothing. This data indicates for 10 months actual demand AT and how the seasons is added into it. In this case, we see a smooth forecast is 11, smooth trend is 2, our forecast including trend is 13. This is how we have done it. Step 1 is forecast for month 2. This is for month 1, we have the data available. Now we have to calculate the forecast for month 2. We'll use the same equation which we mentioned, and we calculated it using the equation which is 12.8 units. Okay. Now, our step 2 will be calculating the trend for the month 2. Okay. We'll be using T2 beta. Okay. You remember alpha is a smoothing constant. When we use trend, then we have 2 values of alpha. Alpha for the forecast and beta for the trend. That's why we are using, this is actually another value of alpha basically. Right. This is beta. Then we calculate the trend using the same equation. We have 1.92 units is our trend. Okay. We see here 12.80 is our smooth forecast. Our smooth trend is 1.92, and our forecast for month 2 is adding 12.80 plus 1.92, we have 14.72. Exactly same step we repeat for month 3, month 4, month 5, month 6, month 7. And this is how we add the trend component in the exponential smoothing.
Right. Sir, it seems that in exponential smoothing we are trying to smooth out the actual demand. Can't we draw the trend line and that will give us relatively a better forecast?
I think that is trend adjustment. We can also make a forecast using the trend. First of all, let's say let's look at the diagram, which is exponential smoothing with the trend adjustment, which we calculated just a few moments ago. This was the actual forecast, and this is the forecast including the trend. We see this is relatively closer than the forecast we have been making with the previous methods. Now you mentioned that can we predict using only the trend line? Yes, we can do it, and we actually start doing that, and then we try to make some adjustment. Let's see how we can do that. In trend, we try to fit the trend line to the historical data. That is actually what we do, and project it into the future for medium to the we fit the historical data to a trend line and then project it into the future. That is what we do, and we do it using the linear trend can be found using the least square technique. I'm sure folks, you are familiar with the least square equation or equation of the straight line y hat equal to a plus bx, which is shown here, where y is computed value of the variable to be predicted, which is a dependent variable. A is the y-axis intercept, b is slope of the regression line, and x is the independent variable. Now the point is, with the variation of the x, what will happen to y? That is basically trend. This is the equation of the straight line. Okay, how we calculate it? Let's see. We call it the least square method, and we are all familiar that what does the least square mean. In fact, if this is our trend line, which is y hat equal a plus bx, and these are our actual observations, y values here 1, 2, 3, 4, 5, 6, 7. These are our actual values. What actually fitting the trend line we are trying to do is we're trying to decrease these values. We're trying to fit the line as best as possible, keeping these data points in line. And least square method minimizes the sum of the squared error. Sum of the squared error. Least square method helps us minimize that. It means this line will be the best approximation of the trend, right? Let's see. Let's now calculate that equation. Our equation is y hat equal a plus bx, where b is the slope of the line, and calculated with this formula. A will be only rearranging this equation. A is equal to y bar minus bx. Now let's try to calculate with the help of an example. This example tells us from year 2001 to year 2007, our time periods are 1, 2, 3, 4, 5, 6, 7, and then our electrical power demand. Okay, folks, all the examples which we are discussing, Ayesha and COL viewers, we use from the textbook which we recommended. For the purpose, because of the time constraint, we only go directly to the solution. For details, you must refer to the textbook, Heiser and other books for the solved examples. Okay, this electrical power demand example is given in the Heiser book. In year 2001, 2, 3, 4, 5, 6, this is the demand. And then we sum up x and calculate x bar, which is 4 here, because we have 7 time periods. Here we sum up y values 692 and we calculate y bar, and here we sum up x squared. You know this x, it is squared in this line, and this is x multiplied by y values here. Here we sum up x squared 140, and here we sum up xy's, which is 3063. Now first of all, we calculate the slope of the line using the formula which we mentioned earlier. It is 10.54, and then we calculate a, which is the intercept of y, which is 56.70. Now we calculate the equation of the trend line is y hat equal 56.70 plus 10.54x. Now this is our value, this is our equation of the trend line. Now will be actually, with the change in the values of the x, our values of y will be coming up. Let's see how it happens. Okay, this is our actual values. We see, this is our actual values, and using our trend line is y hat equal 56.70 plus 10.54 x. This is our trend line. As we if we increase this trend line into future, that will give a good approximation of our forecast.
Sir, we know that season impacts the consumption of goods and services. How do we incorporate the seasonality with the forecast?
Ayesha, it's very important that the seasons are taken care, because in business, I think we previously discussed the examples of, let's say, if there is a Christmas season, or if there is a holiday season, or if there is a rainy season, or if there is snowfall, certain products and services can have the season can have impact on the demand for the products and services. For example, demand for the park services or recreational services during a holiday season will be more. And similarly, there can be, let's say, demand for travel services will be more in holiday season, and so on. As such, adding the seasonality component in your forecast is absolutely important. Let's see how we do it. There are a number of steps if we want to incorporate the seasonality into our forecast. There are a number of steps to be followed, and these steps are as follows. Number one, we find the average historical demand for each season. Straightforward. It's simple, plain and simple. Then compute the average demand over all seasons. It is again plain and simple. Compute all seasonal index for each season. How we do that we'll be discussing shortly. Then estimate next year's total demand. Then divide this estimate of the total demand by the number of seasons. Then multiply it by the seasonal index for the season. Now, how we do it, let's see with a practical example. This data shows from January to December for year 2005, 2006, 2007. This is the demand data. What we do is we calculate average from 2005 to 2007. These 3 years, average demand 80 plus 85 plus 105 divided by 3, we calculate the average demand, right? And then it goes on all the way for these 12 months. Then we calculate average monthly demand for the complete data. Average monthly demand we calculate, which is 94, consistently 94 across our previous historical data period. Now we calculate the seasonality index. How do we do that? It is, as I mentioned in the steps earlier, average of 2005 to 2007 monthly demand divided by average monthly demand. That is 90 divided by 94, which is 0.954. It means 9.954. It is closer to next month's demand will be closer, almost closer, because whatever this is our seasonality index. Okay. Now let's move forward. We calculated seasonality index for all the months: February, March, April, May, June, July, August, September, October, November, and December. Here we see when our seasonality index is 1.064, that means during this month our forecast for the next month or for this month, where our seasonality index is more than 1, will be slightly higher. Here slightly even more higher. Here again a little bit less than decreasing. Okay. Seasonality index actually tells us whether the demand during the next period will be increasing or it will be decreasing. Now, forecast for the year 2008, how we do it. Expected annual demand is, let's say, 1200. We divide it by 12 because we have 12 seasons and multiply it with 0.957, which is our seasonality index. For January, our demand will be 96. For February, same thing, multiplied by a different seasonality index, which is 0.851. Here, you see, and then our demand will be 85. Our forecast for year 2008, February 2008 will be 85. And similarly, we calculate for all other months.
Right. Sir, we got it theoretically that...
Okay. Before we get into, Ayesha, your question, let's see how the graph looks like. This is, for example, we see our 2005 demand. This is our 2006 demand. This is our 2007 demand. And this is 2008 demand, which captures the seasonality index as well. And we see they are fairly consistent. Means in this season, our demand is high, whereas from January, February, March, our demand is low. Then starting from August onward, again demand starts decreasing. And higher demand is from April, May, June, the demand is higher. May is the highest. Okay, this is how we capture seasonality index in our forecast.
Right. So we got it theoretically that seasonality can be included in the forecast using the seasonality index. Will you give us some example practically?
Okay. Yes. I mean, there can be numerous examples. Here I'll present you an example of San Diego Hospital, which is also given in your Heiser book. This diagram indicates the trend data, and this is the trend line, which is the inpatient days. This is the projection of inpatient days from January 67 to December 78. It means it is 67, 68, 69. It is, means each year succession we go here. And our trend data says in January 67, our demand was 9,530. Our trend data tells us. And in December 78, it was 9,766. Now, we need to have, in order to use seasonality index and adjust this trend data, incorporating the seasonality index, let's look at that. This diagram indicates the seasonality index for the same period and independent index of inpatient days. They have calculated for Jan 67, it is 1.04, for Feb it is 0.97, and so on. This is the seasonality index. Okay. Now what actually we are going to do is we are going to multiply the seasonality index with our trend data. How it happens? Okay. This diagram combines the trend and seasonal forecast. Our trend line was there. Whatever was our trend figure, we simply multiplied that with the seasonality index, and we got 9911. And for the second month, for third month in the third year, and so on. This 9911 is simply, it is a multiplication of 9530 and our seasonality index, which is 1.04, will give us the combined trend and seasonality forecast. It means we have now, in this diagram, we are showing three things. A, we are showing the actual forecast, then a derived trend, and then seasonality index. It is a forecast adjusted for trend, adjusted for seasonal forecast. This is a practical example of inpatient days at San Diego Hospital.
Thank you, sir. Ladies and gentlemen, in this session, we discussed exponential smoothing with trend adjustment. We also used trend prediction using least square method for forecasting, and we learned how the seasonality index is developed and used in forecasting. Well, viewers, this is it for now. See you next time with a new topic. Till then, thank you and Allah Hafiz.